Hi guys, you ready for the most fun you've ever had sitting at home? Yeah, this is going to be exciting. Okay, I'm teaching you about exponents. Now you already know some about exponents, but there are rules and shortcuts that we're going to learn. It can seem long and tedious. Just hang in there. If you have to watch a little bit and then stop, then go back, that's fine. We'll have the video posted of me explaining all the notes, and then I will also post just the slideshow so you can go back and look at them as if you had them written down, and you can use that to do your homework and everything. All right, you ready to get it started? Okay, here's our lovely table, and it's going to have all the rules here. That's called the property name. It's going to have a definition. That means what it looks like written in math speak. And then over here an example of what that rule actually looks like in numbers. Okay, at the top here it says let A and B be real numbers. That means it could be any number that you could think of. Positive, negative, decimal, fraction, repeating, non-repeating. And let M and N be integers. Remember, integers are only positives and negatives. They have to be whole numbers. Okay, so our first rule or property is called a product of powers. Now, I don't really care that you know the name of the rule. What I care is that when you see it in numbers and in math, you know what you have to do. Okay, but the reason that this first one is called product of powers is because product means you're multiplying, and it means you're going to be multiplying powers. So this is what it looks like. Remember that A's are real numbers, so any number you can think of, and the M and N are integers, positives or negatives. So what this rule says is when I am multiplying two bases that are the same, I'm going to keep that base and I'm going to add the exponents. So for you, you might see a problem that looks like this. 5 to the third times 5 to the negative 1. You see that you have two bases that are the same, 5. Keep the 5, add the exponents. So when you add 3 plus negative 1, you get 2. So the problem becomes 5 squared. Now 5 squared you can do in your head, that's 25. So a problem that looked like this, you're like, what the heck is that? Becomes really easy, it becomes 25. Okay, power of a power. So this means you've already got one exponent and you're going to take it to another exponent. So it looks like this. Notice you have one base, you have the A, and you have two powers, you have an M and an N. All that means is keep that A and multiply the exponents. So it might look like this. 3 to the 4th squared. Keep the 3, multiply the 4 times 2, you get 8. And then you can use your calculator. What's 3 to the 8th? 6,561. Now, I know that you can go and you can put this in the calculator, and you're going to get out the 6,561. Okay? The point is that you're trying to learn some shortcuts and some rules. And because you're not always going to use them on numbers, sometimes you're going to use them on letters, and you can't put the letters in your calculator. So as you're doing this, you need to show me that you know what the rule is that you applied before you go to the calculator. The calculator is going to be kind of minimally used, not a whole lot. Okay? So when you're doing these, if all you're doing is writing down the problem and showing me the final answer is 25, you're not going to get any points because I know you know how to use the calculator. All right, our third rule, power of a product. That means you have a product, two things that you're multiplying, and you're going to take it to a power. So you're going to have something that looks like this. Notice inside the parentheses you have two bases and they're different. One is A and one is B. And you only have one exponent. What that means is you take the exponent and you distribute it to each base. Okay, so numerically it might look like this. 2 times 3 to the 4th is the same thing as 2 to the 4th times 3 to the 4th. You put that in the calculator, you get 1,296. Now you could also do inside parentheses, do the 2 times 3 and get 6. And then you would have 6 to the 4th. If you put 6 to the 4th in calculator, you're also going to get 1,296. Okay? Because you're not really normally going to see a problem like this with two numbers. What you're normally going to see is like one number and a letter or more letters. Now, students are real good at remembering to put that 4 on the x, but then they'll forget about the 3. And what this rule is saying is that 4 has to go to the x and it has to go to the 3, just like this. So now the only part you need the calculator for is what is 3 to the 4th, and that is 81. So 3x to the 4th is the same as 81x to the 4th. Okay, our next rule is a negative exponent. You will see exponents that are negative. Okay? Now, what this means is that I'm going to see a base and it's going to have a negative exponent. So what I'm going to do is I'm going to take that base, that a, and I'm going to use the reciprocal of it, which is 1 over a. And then that makes my exponent positive. So the act of flipping the base is what makes the exponent positive. So you might see a problem like this. 7 to the negative 2 equals 1 over 7 squared. Okay, because I see the 7 to the negative 2. I'm going to take the 7 and flip it to 1 over 7. And then my negative 2 becomes a positive 2. So that becomes the same thing as 1 over 49. You might also see it like this. 1 over 9 to the negative 2. So I'm still going to take that 1 over 9 and I'm going to flip it. So now my 9 becomes on top. It becomes a whole number 9. And my negative 2 becomes positive. So now the problem is 9 squared, which is 81. Okay, we're going to have 0 exponents. 0 exponents are super easy. Any number to the 0 power is always going to equal 1. Because you don't have any of them. You just have 1. Except for 0. You can't take 0 to the 0 power and get 1. So what this means is I could have a whole number like 3 to the 0 power and it's going to equal 1. Or I could have a large number like 15,652 to the 0 power. It's going to equal 1. I could have a negative number like negative 89 and have it to the 0 power and it's going to equal 1. Okay, quotient of powers. Quotient means you're dividing. So dividing of powers. Okay, now this goes hand in hand with our first rule. On this one, you were multiplying the same base, so you added the exponents. Multiplication, addition. On this one, we're dividing the same base, so we're going to subtract the exponents. So you might have a problem that looks like this. 6 to the negative 3 over 6 to the negative 5. So I'm going to keep the 6 and I'm going to subtract the exponents. Negative 3 minus negative 5. That's the same as negative 3 plus 5. And negative 3 plus 5 is 2. So it becomes 6 squared, which is 36. On that one, you didn't even need to use the calculator at all. Okay, power of a quotient means you have two things being divided and you're taking it to a power. So this one goes hand in hand with this one up here, the product of powers. Here you're multiplying two different bases. Here you're dividing two different bases. You distributed the exponent. You distribute the exponent here. So it might look like this. 4 over 7 squared. 4 and 7 are not the same base. They're being divided. So I distribute the 2. It becomes 16 over 49. Now, what we're going to do is we're going to practice these a little bit. So let's say we start with this problem up on the left. We've got negative 4 times 2 to the 5th in parentheses, all squared. So you start inside the parentheses, okay? Inside the parentheses, you have two different bases. And you only have a power on this one. So there's not really anything you can do inside here, okay? So what we see is we have two different bases with one exponent on the outside. When you have that rule, you distribute the 2. So it's going to become negative 4 squared times 2 to the 5th squared. So all I've done is rewritten it the way it looks. Notice I still have parentheses around that negative 4. Because remember, this says take negative 4 and square it. Negative 4 times negative 4 is positive 16. if I don't have those parentheses, it says square the 4 and then make the answer negative. So I would get negative 16. Your parentheses make a huge difference here. Do not forget them. Okay, so we already went over that negative 4 squared is 16. Now, on the second part, you've got one base and you've got two exponents. So the rule was to keep that one base and multiply the exponents. So this becomes the same as 16 times 2 to the 10th. Now, you put 2 to the 10th in the calculator, and you get 1,024. Then you multiply that by 16, so your final answer is 16,384. Okay, the problem to the right, we have 11 to the 5th over 11 to the 8th, all to the negative 1 power. I would start inside the parentheses. And inside the parentheses, you have 11 to the 5th over 11 to the 8th. You got the same base being divided. That means keep the base, subtract the exponents. So 5 minus 8 is 11 to the negative 3. And then on the outside, you still have this negative 1. So now what we've got is one base, the 11, and two exponents. So you keep that base and you multiply the exponents. Negative 3 times negative 1 is 3. So we get 11 to the 3rd. Put that in the calculator, and you get 1,331. Okay, our next problem. Negative 3 squared times 5 to the 3rd. This is the same kind of problem as the top one. So the first thing you're going to do is distribute the 3. Now, down here, we have negative 3 squared. Notice there's no parentheses between that negative 3 and the 2. So that means you're going to do 3 to the negative 2 first. Okay? Or what you're taking is just this negative 3 and you're going to multiply the 2 times the 3. Because you have one base and you have two exponents. Okay? So 2 times 3 is 6. So we're going to get negative 3 to the 6th. And then we have 5 to the 3rd. Now, putting negative 3 to the 6th in the calculator that way, you're going to get negative 729. 5 to the 3rd is 125. And then we multiply, so our final answer is negative 91,125. All right, our last problem here, 1 to the 4th over 3 squared, all to the negative 1, is very similar to the problem above it. Except this time, inside the parentheses, we have two different bases. Okay? So we can't do anything with the 1 to the 4th and the 3 squared other than to figure out what they equal. So we get 1 over 9 to the negative 2. Now you have two bases being divided with one exponent. So you distribute the exponent. So it becomes 1 to the negative 2 over 9 to the negative 2. Again, my bases are not the same, so I can't subtract the exponents. They're negative, though, and I don't want them to be negative, so I'm going to take the 1 over 9 and I'm going to flip it. So now my problem is just 9 squared, which is 81. Okay? When you are doing your homework, use that table to discern which rule it falls under. Okay? And you can do them in different orders. This is why it's really, really important for you to show me your work. On this problem, I didn't have to start inside the parentheses. I could have distributed the negative 1 first and made it 11 to the negative 5 over 11 to the negative 8. This one, I could have distributed the negative 2 first, so it became 1 to the negative 8 over 3 to the negative 4. So you have to show me how you're applying the rules. You need to show me the various steps. Okay, next thing. Scientific notation. Now, the reason that we're going to go over scientific notation. I know you've all learned it. You may or may not remember how the heck it works. What is important about scientific notation is it's used to express really, really large numbers, like 250 billion, or really small numbers. Like, I can't even read that. I don't know what it is. So you'll have scientists that are using these. Let's say they're talking about space and how far apart things are. They're billions of miles apart, billions of light years apart. Or they could be working with very, very tiny things like atoms and protons and neutrons inside of atoms. And they get very, very small. If you are a machinist, depending on what you're making, you may be using very, very tiny numbers. When my husband was a machinist, for a while, he was making medical parts, and they had to be perfect within, this much of an error. So scientific notation came into play a lot. Okay, so anyways, instead of writing out 250 billion like this, remember that what you're going to do is you're going to take the decimal point from the end and you're going to move it behind the first non-zero digit. So I'm going to have the 2.5. And then I'm going to multiply it times 10. And the power in the 10 will be how many places I move that decimal. So I move the decimal from here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So 250 billion becomes 2.5 times 10 to the 11th. 3,600 will become 3.6. And then I only move the decimal place 3 places. So 3.6 times 10 to the third. Now, when this is a positive number, your exponent, when your exponent is a positive number, that means it's a large number. Okay? To express little numbers, you're going to use negative exponents. So again, I'm going to take this decimal, and I'm going to put it behind the first non-zero digit. So I'm still going to have 2.5. And then I'm going to count. I moved it 1, 2, 3, 4, 5, 6, 7 places. So it'll be 2.5 times 10 to the negative 7. Okay, my 0.0036 will become 3.6 times 10 to the negative 3. Okay. Now you'll have to use that about moving them and whether you're adding or subtracting the numbers in order to get your final answers. So when you have moved the decimal point from the right to the left, you're adding numbers on. When you're moving the decimal point from the left to the right, you're subtracting numbers. Okay, so you're going to have some problems like this. 4.2 times 10 to the third times 1.5 times 10 to the sixth. Now this looks complicated. And if you put it in a calculator, you're going to get some weird answer that you're not going to understand what it is necessarily. So to multiply this is really easy. The first thing you're going to do is you're going to take those numbers there and you're going to multiply them. And then you're going to multiply 10 to the third times 10 to the sixth. Like this. I've just regrouped them. Now in your calculator, you're going to put 4.2 times 1.5. And we get 6.3. And then on the tens, you're going to use the rule that you know. I have two bases that are the same, 10. So I keep the base, and I add the exponents. So this becomes times 10 to the ninth. Okay, that's it. Now, because I only have one non-zero digit number in front of the decimal point, I don't have to, it's already in scientific notation. I don't need to move it. I don't need to change this number. Okay, now this problem down here is division. But it's going to work the same way. I'm going to divide the whole numbers, and I'm going to divide the tens with the powers. So now you're going to put 8.1 divided by 5.2 in your calculator, and you get 1.5. And then we're going to do 10 to the 12th over 10 to the 9th. I have the same base 10. I'm dividing them. So I keep the 10. I subtract the exponents. 12 minus 9 is 3. So I get times 10 to the third. Okay, we are going to use these rules to simplify expressions. Notice there's way more letters than there are numbers. Okay, so on my first one, b to the 4th, b to the 6th, b to the 7th. When I have my letters written right next to each other, that means multiplication. So I've got 3 of the same base that I'm multiplying. Keep that base, add the exponents. So we're keeping the b, and we're going to take -4 plus 6 plus 7. Put that all in the calculator, and you get b to the 9th. And since you don't know what b is, that's it, you're done. But notice you can't use a calculator for this. You have to know the rules. Okay, my next problem. R to the -2 over s cubed all to the -3. Okay, inside my parentheses, the bases are not the same. I have an R on top and an S on the bottom. So I automatically can't do anything with those. Okay, so inside parentheses is done. So I go to the outside of the parentheses. Outside the parentheses, there's only one exponent, so that means I'm going to distribute it. Okay, so in order to distribute it to here, to the top, when I've got one base and 2 exponents, it means keep the base and multiply the exponents. So it becomes r to the 6th. On the bottom, I get the same thing. S to the 3rd to the -3rd. So 3 times -3 is -9. Now, I still can't do anything with the r and the s because they're different bases. So I'm going to look at them separately. On the top, I've got an r to the 6th. That one's fine. I don't need to do anything with it. But on the bottom, s to the -9, I can't keep that -9 there. I want it to be positive. So to do that, I'm taking the s on the bottom, and I'm going to flip it up to the top with the r. And then that makes the 9 positive. Okay. On the bottom, what we're going to do is we're going to kind of separate this. We're going to take the 16 and the 2. Those are whole numbers. We're going to keep them together. I've got an m to the 4th on the top. I don't have any m's on the bottom. So that m to the 4th is all by itself. And then I've got an n to the -5 and an n to the -5 top and bottom. Okay? So I'm going to split it up like this. When there's no m to pair with it, I'm just going to put it over 1. Now basically I've got 3 different problems. And I'm going to do each one of those problems separately, then stick them back together. Okay? So I'm going to tackle the 16 over 2. What is 16 over 2? It's 8. Then I'm going to look at the m to the 4th over 1. That's just m to the 4th. That doesn't change at all. Now, n to the -5 over n to the -5. 2 different ways to look at this. You have the same thing over top of each other. That anything, when you have 3 over 3, 10 over 10, that always equals 1, right? The other way to look at it is I have 2 of the same base being divided. So I keep that base and I subtract the exponents. -5 minus -5 is the same as -5 plus 5. -5 plus 5 is 0. Anything to the 0 power is 1. Now, what I have to do is I have to multiply these together. 8 times m to the 4th times 1 is 8m to the 4th. And by the way, my coughing, I don't have corona. I am choking on air. Because, that's me. Okay, we got some more we're going to practice here. A to the -3b squared over a to the 5th. Again, we're going to pair them up. So I've got 2 a's to pair up, and I have just a b by itself. Okay, on here, same base being divided. Keep the base, subtract the exponents. So I have -3 minus 5, which is -8. So I end up with a to the -8 times b squared. Now my b squared is positive, can't do anything with that. My a to the -8 though is negative, so I need to flip that. So my a, instead of being on top, has to go to the bottom. So I get b squared over a to the 8th. My B and A are not the same. I cannot do anything else here. And each one only has one exponent, so you're done. Okay. My next one, xy squared squared over x cubed y to the negative 1. All right. When you see this and you have parentheses, try and start where the most stuff is. Okay? So on top, we have the most stuff. Inside these parentheses, you have two different bases, so you can't do anything with those. But you have the one on the outside, so we're going to distribute it. So the top is going to become x squared y to the 4th. My bottom has stayed the same. Now I split it up just like the problem above it. So I've got x squared over x cubed and y squared over y to the negative 1. X squared over x cubed, same base, keep the base, subtract the exponents. So 2 minus 3 is negative 1. I get x to the negative 1. Y to the 4th over y to the negative 1. Keep the y. 4 minus negative 1 is the same as 4 plus 1. So I get y to the 5th. Now my x to the negative 1 can't stay negative, so I got to shove it to the bottom. So my 1 becomes positive. When I have a positive 1 as a power, I don't have to write it down. If you want to write it down to make it y to the 5th over x to the 1st, that's fine. I will not mark you off for it. Okay, our next problem, 7b to the negative 3, all squared, b to the 5th, b. All right, so we're going to take care of those parentheses. We don't like the parentheses there. So inside the parentheses, you've got two different bases, and we've got one exponent on the outside. So we're going to distribute the exponent. So I'm going to get 7 squared, and when I've got the b to the negative 3 squared, I'm going to multiply those exponents. So I'm going to get 7 squared, b to the negative 6th, and then I took these two b's on the outside, b to the 5th times b, keep the b, add the exponents. So 5 plus 1 is 6. Okay, 7 squared is 49. When I have my b to the negative 6 times my b squared, keep the b's, add the exponents. Negative 6 plus 6 is 0. B to the 0 power is 1. So I have just 49. 7 squared times 1 is 49. Okay, I know it's a lot to take in. Keep going back to these notes as you're doing the homework so you can double check the steps. Do them one by one. Show every single thing that you're doing. Do not try to do the stuff in your head. Obviously, when there's letters, you can't go to the calculator and double check your answers. So you have to get used to using these rules. Okay, you can do it. I know you can. Remember that I'm here for questions. Okay, we've got one more example about how it might be used in real life. Okay, this says Betelgeuse is one of the stars found in the constellation Orion. Now, this is an actual star. It's actually named Betelgeuse. If you have seen the movie Beetlejuice, he's named after this star. They just spell it different. Okay. It is a huge star. Its radius is about 1,500 times the radius of the sun. How many times as great as the sun's volume is Betelgeuse's volume? Okay, so this seems like a very, very complex problem, but it ends up being super easy. Okay, so the first thing we need to know is how to find the volume of a sphere, because the sun and Betelgeuse are both spheres, right? Okay, so 4/3 pi r cubed. That's how you find the volume of a sphere. Now, we don't know the radius of the sun. Not off the top of our head. So we're going to call it r. So that means when I do this, that's giving me the volume of the sun. Okay, because I took that r and I plugged it in here, and I got the volume of the sun. Now, I don't know Betelgeuse's radius either, but I know it's 1,500 times the radius of the sun. So Betelgeuse's radius has to be 1,500 r, right? So to find Betelgeuse's volume, I'm going to take this radius and I'm going to plug it in here, right? Notice I kept the 4/3 and the pi. I took the r out and I put the 1500r in its place. Okay, now you're going to use your exponent rules, and what we're going to do is we're going to compare them. Okay, so when you're comparing Betelgeuse's volume, this, to the sun's volume, this means you're going to divide them. Okay, so the first thing I did is I distributed my 3 out here. I distributed it to 1500 and to the r. So that's my area for Betelgeuse. Betelgeuse's volume divided by the Earth's volume. Now, this looks crazy, and you're probably thinking there's no way on Earth that you're going to be able to figure this out. But let's break it down. Okay? We see similar things on the top and the bottom. And remember, whenever you have the same thing on top and bottom, it just cancels out to 1. So I have a 4/3 pi on top, and I have a 4/3 pi on the bottom. Those get to go away. Now I have a 1500 cubed on top. I don't have one on bottom. I have an r cubed on top and an r cubed on bottom. So those get to go away. So the only thing left is this 1500 cubed. Betelgeuse's volume is 1500 cubed times bigger than the radius of the sun's volume. Okay, so if you want to know what that is in numbers, you put 1500 to the third in your calculator, and you get 3,375,000,000 times greater than the volume of the sun. Okay. Now, there's been some weird stuff, some kind of cool stuff going on with Betelgeuse that I'm going to attach a little YouTube video if you're curious, if you'd like to see it. I thought it would be neat to add it on because, you know, this is real life and this is where some of the math comes from. After that, this is your assignment. You will be doing numbers 2 through 42 even. Notice it's just the evens. Do not do all the problems. Okay? You have until 8 p.m. tomorrow, March 31st, to get all this done. At that point, when you have turned it in, then I will post for you the answers, and I'll post a video showing me actually solving them, so you can have that explanation. Remember, if you have further questions, please contact me, because you're still going to have to take a test and everything on this, okay? All right, guys. Hope it's all going well. Hope you're all still healthy, and I will talk to you later. Bye.